So, hello everyone. Welcome to Ekeeda. So, hello everyone. Welcome to Ekeeda. And today, our topic is, you know, again, our topic is forecasting and queuing theory. Okay. So, in this lecture, we will discuss some of the questions. Okay, which have been asked in the any examination. Okay, just we will revise the concepts and we will solve some of the important questions. Okay, so the first question I have already written. Okay, so this is the question number one. So first we will read the question. Okay, so it says that the demand for a certain raw material used in a manufacturing organization varies from month to month. Okay, and then they are saying that the consumption pattern of the material during the last 6 months in metric tons is given below. Okay, so you can see there is a table. Okay, so this table basically gives the month and its demand data. So we have got the records of last 6 months, month 1, 2, 3, 4, 5, and 6, and the corresponding demand data for each of the month has been given, and it is basically the consumption pattern of a material. Okay, so the first question they are saying that using the method of moving average, forecast for the demand for 7 months using 3 period moving average method. Okay, so what they are saying, first they are asking that using 3 period moving average method. Okay, they are saying that using 3 period moving average method, find the forecast or demand for the seventh month. Okay, month 7. So what we have to do, since it is a 3 period moving average, so it is one of the part of the time series forecasting. Okay, in time series forecasting, we have got 4 classification. So one of the classification is moving average method. Okay, so the first classification, so the 3 period moving average says that we have to use only 3 period. You can say we have to use only 3 period data. So which are those three? We can use only the latest demand. Okay, so for the seventh month, the latest will be 6th, okay, 5th and 4th. Okay, these three are the latest. Okay, these three are the latest. So what we will do, we will write here demand or forecast. You can write demand or forecast. You can write basically forecast for 7th month is equals to demand of 6th month plus demand of 5th month plus demand of 4th month divided by the average. Okay, very simple. Okay, they are saying the 3 periods, so you have to consider the records of only 3 months and take the average. So demand for the 6 months, you can see it is 60 plus for the 5th month it is 50 and for the 4th month it is 40 divided by 3, so we will get 50. Okay, in metric tons. Okay, in metric tons, so our answer is 50 metric tons. Okay, this is our first answer. Okay, this is our first answer. Second one, what they are saying, second one they are saying that suppose, they are saying that suppose the 3 period have the weights of 0.5 for the immediate past and 0.25 for the 2 and 3 periods before, what will be the new forecast? Okay, so since they have given the weights, okay, since they have assigned the weights, so we can say that the second method is all about weighted moving average method. Okay, it is all about weighted moving average method. Okay, it is all about weighted moving average method. So you can see they have said that the weights are given. So for the sixth month, they have assigned the weight 0.50. Okay, and for the immediate past and for the immediate past they have assigned 0.50. Okay, they have been written. Okay, and we also know that we have to assign highest weight to the recent demand data. Okay, so sixth month is the recent or latest, so the weight is highest for the immediate past and 0.25 for the 2 and 3 periods before. So for the fifth month it is 0.25, and for the fourth month also it is 0.25. Okay, like this they are given. So what they are asking, they are asking that find the forecast for the seventh month, find the forecast for the seventh month. So what we are doing, according to weighted moving average method, what we are doing, we are simply multiplying the demand into weight, d6 into w6, d5 into w5 plus d4 into w4. Okay, so just you have to multiply the demand data with the weight and take the summation. So it is for the first it is 60, demand is 60 and the weight is 0.50 plus the demand is 50 and the weight is 0.25 plus the demand is 40 and the weight is again 0.25. So you can take the summation of all. So what you will find, the answer you will get is 52.5. Okay, this much of metric tons. Okay, because in the question only they have said that the demand is in metric tons, so 52.5 metric tons. So this is the answer of the second question. Okay, so with the help of this question we have also came to know about moving average method and weighted moving average method, and these questions are very much important. Directly 1 or 2 marks questions are asked in the examination. Okay, so very simple one, just you have to learn or practice 1 or 2 question only. Now the third one, the third question. Okay, the third question, it says that changing the number of periods. Okay, changing the number of periods for the moving average to 2, 4 and 5. Okay, so they are saying that if in spite of 3 period moving average, if they are using 2 period moving average, 4 period moving average and 5 period moving average, then they are saying that obtain the forecast in each of these cases for the seventh one. Okay, so what we have to do, we have to find the forecast for the seventh month using 2 period weighted moving average method, using 4 period weighted moving average method and using 5 period weighted moving average method. So the third part, they are changing the moving average method. Okay, so first they are saying that use 2 period. Okay, suppose they are saying that use 2 period moving average method, that is MAM, 2 period moving average method. Now what we have to do, we have to find the forecast for the seventh month. So since we are using only 2 period, okay, so what we have to do, we have to consider the latest demand data, and the latest demand data is sixth month and the fifth month. Okay, only 2 period. Okay, only 2 period we have to take. So the latest will be 6 and 5, so it will be d6 plus d5 average. Okay, divided by 2, so it is going to be 60 plus 50 divided by 2, so it is 110 by 2, so it is going to be 55. Okay, it is going to be 55 metric ton, 55 metric ton. Now in this question only they are saying that if you are using 4 period moving average method. Okay, now They are saying that use 4-period moving average method, and you have to do the same thing. You have to find the forecast for the 7th month. So what you will do, since they are saying that use 4 periods, so we have to consider the records of 4 months, and that 4 month will be the latest. So we will start from the 6th one, first, second, third, and fourth. Okay, we will remove first and second. So what we will do, d6 plus d5 plus d4 plus d3 divided by average, so 4. So it is going to be 60 plus 50 plus 40 plus 20 divided by 4. So answer you will get 42.5 metric tons. Okay, 42.5 metric tons. Now, in this question only, they are saying that they have to use 5 period also. Okay, they are also saying that what will be the forecast for the what will be the forecast for the 5 period. So they are saying that use the 5 period moving average method. So once again, okay, they are saying that 5 period moving average method. So what we have to do, we have to consider the records of the 5 month, because we have to use 5 period moving average, and that will be the start from latest. Okay, that will start from the latest. So just write from the latest, d6 plus d5 plus d4 plus d3 and plus d2 divided by total number. Okay, it means we have to take the average. So 5 period means divided by 5. So the demand is 60, 50, 40, 20, and the last one was 30. Okay, it is 30 divided by 5. So what you will get, you will get 40. Okay, 40 metric tons. So all the answers we have calculated. Okay, so using 2 period moving average method, using 4 period moving average method, and using 5 period moving average method, all the answers we have calculated. So now we will again go to the question, and last question we will see. Okay, last question number 4, very important question. Okay, very important part. What it is saying, it is saying that what do you conclude from the results obtained in 1, 2, and 3? Okay, so they are saying that what is the conclusions you are obtaining from the first question, second question, and third question. So you can see in the first question, the answer is 50. Okay, in the first question the answer is 50. In the second question the answer is 52.5. Answer is 52.5. And in third question you can see we have got 55 for the 2 period moving average method, 42.5 42.5 for the 4 period moving average method, and 40 for the 5 period moving average method. You can see that the final forecast, okay, final forecast for the 7th month is decreasing. Okay, it is decreasing in nature as we are increasing the number of periods. Okay, you can see we are increasing the number of period from 2, 4, and 5. As we are increasing the number of period, the forecast value is decreasing. Okay, it is decreasing. Okay, it is decreasing. So what you will conclude, and you can see the demand data. For the first month it is 20, for the second month it is 30, for the third month it is 20, and fourth, fifth, and sixth. You can see the demand data is increasing in nature. Okay, demand data is increasing in nature. It is 40, it is 50, and it is 60. The demand data is increasing in nature. So the forecaster will try to think that if I have to calculate the demand for the 7th month, then the value must be greater than 60. Okay, the value must be greater than 60 because he has seen the trend. Okay, he has seen the trend data that for each of the month 40, 50 and 60, for each of the month the demand data is increasing. For the seventh month also the demand data must increase. You must follow the trend value. So what we will write for the fourth part? ओके, फोर्थ पार्ट क्या लिखेंगे हम लोग ये लिखेंगे कि सिंस द डिमांड डाटा is increasing, since the demand data is increasing, that is it is a trend data. Okay, increasing data we can say it is following a trend, so it is also known as trend data. So what we will do, we should use or prefer we should prefer the casual method. Okay, basically the moving average method is a classification of time series analysis. Okay, and the second classification was casual method. So since the data is trend data, so we should prefer the casual method compared to time series forecasting. Okay, so we should use, okay, if they are saying that what you should use, so we should use the casual method as compared to time series forecasting. But if we have to use time series method only, then the number of periods should be as low as possible. Okay, if we have to use time series method only, then the number of periods should be as low as possible. The number of periods should be as low as possible, because we can see as the number of period is low. Okay, for 2 period it is 55, for 4 period it is decreasing, and for the 5th period it is least. Okay, सबसे कम है 5th period के लिए 40 मेट्रिक टन, 4 period के लिए 42.5 मेट्रिक टन एंड 2 period के लिए 55 मेट्रिक टन. एंड सिंस हम जानते हैं कि डिमांड डाटा इज इंक्रीजिंग इन नेचर. ओके, डिमांड डाटा इज फॉलोइंग ए ट्रेंड, so we should use a number of period that should be as low as possible to follow the trend. Okay, so we can conclude these things from the above questions. Okay, so very simple question. Okay, the formulas are very simple, but you should also know the basic concepts also, that what does it mean. Okay, now we will move for the second question. Okay, you can see we have taken the second question here. Okay, very important and very conceptual question. Okay, बहुत ही अच्छा क्वेश्चन है, आप देख सकते हो. So अपने पास second question. So question number 2, it says that the annual sales, okay, the annual sales is given. The annual sales of a company are given below. Okay, so you can see year we have got 5 year 90, 80, 90, 81, 90, 82, 90, 83 and 90, 84. Okay, so we have got 5 year, and the sales in rupees of each of the 5 year has been given: 50,000, 65,000, 75,000, 52,000 and 72,000. Okay, so each year sales value is given in rupees. So what they are saying, that by the method of least square, okay, by the method of least square, find the trend value for each of the 5 year. Okay, so they are saying that we have to use the method of least square. We have to use the method of least square, and by using this method we have to find the trend value for each of the 5 year, and also estimate the annual sales for the year 1985. Okay, so we cannot use here moving average method or weighted moving average method. Okay, because they are saying that we have to use the method of least square. So this method is one of the parts of the casual method. Okay, it is one of the part of the casual method, that is method of least square. So what we will do, first we will make the table. Okay, first we will make the table. First we will make the table. So what we will do, in the first column we will write year. Okay, in the first column I am writing year. In the second column I am writing the sales data. Okay, in the second column I am writing the sales data, that is sales. Okay, sales is written. So we have been given these information. Okay, year versus sales data. So 1980, 1981, 1982, 1983, and 1984. Okay, 1984. So we have written the data. Now we will write the corresponding sales value. So I am writing it 50. Okay, 50 means I am writing it in thousand. So sales I am writing in thousand. Okay, in rupees, in thousands. In the last we will multiply with the thousand. So to make our calculations easy, I am writing it 75. So 75,000 simply 75, 52,000 simply 52, and it is 72. So I have written it. So how to use the method of least square? You know that in this method we have to establish a relationship between dependent variable and independent variable. Okay, we have to establish a relationship between dependent variable. Okay, there are dependent variable and there are independent variables. So we have to establish the relations between these two variables. So basically, what is dependent variable? The dependent variable is always demand. Okay, it is the demand, or here the sales data. Okay, sales data is given, that is our demand data. And what is the independent variable? Independent variable can be the salary of the customer. Okay, it can be the population. Okay, these things are independent variable. Okay, these things are independent variables. So we have to find the demand of the data according to the salary or population, or you can say year. Okay, here year is our independent variable. So what we will do, the dependent variable is considered as y. Okay, and the independent variable is considered as x. Okay, so we have to establish a trend equation. We have to form a trend equation between the dependent variable and independent variable, dependent variable and independent variable. So what we will do, we try to form a equation. Okay, that is equation is simply linear regression equation, that is y equals to a plus b x. Okay, you can see this is our demand data and this is the year value, or you can say this is the independent variable and this y is the dependent variable. So these a and b are the two constants. So if anyhow, if we find the value of a and b, okay, अगर किसी भी तरीके से a और b की वैल्यू हम फाइंड कर लेते हैं, then for different values of x, for different values of x we can calculate the value of y. Okay, so they are saying that we have to calculate the sales for the year 1985 also. Okay, so already we are knowing the value of x. So for this x, we have to find the y. So first, what we have to do, we have to calculate the value of a and b using some mathematical operations. Using some mathematical operations. So what we will do, we will consider these cells as, we will consider this cells data as our y. Okay, that is our dependent variable. That is our dependent variable. Now you can see we are not assuming this year at x, okay, because it will make the calculation very lengthy. Okay, it will make the calculation very lengthy. So what I am doing, I am writing a new column or new table for x. X is our independent variable. Okay, so I'm writing a new column for x. So how to assign the values of x, how to assign the values of x? Okay, either you can assume this 1980 to be 0, this 1, 2, 3, 4, or you can assume 1, 2, 3, 4, 5, anything. But for simplicity, what we are doing, but for simplicity, what we are doing, the method of least square only says that try to make the summation of x value as 0. Okay, try to make the summation of x value as 0. So how to make the summation of x as 0? Okay, what we will do? In this equation try to use the summation. So summation y will be equals to summation of a will be a times n plus b summation x. Okay, b summation x. So the method of least square says that try to make the summation of x, try to make the summation of x as 0. Okay, it will make the calculations very easy. Okay, it can make, it will make the calculations very easy. So from here we can calculate the value of a we will get summation y divided by n. Okay, summation y divided by n, like this. And how to find y? Okay, how to find y? What we will do, this equation y equals to a plus bx. Okay, so multiply with x both sides, that is xy equals to ax plus bx square. Okay, we are multiplying with x both sides and try to take the summation. Now it will be summation xy equals to a summation x plus b summation x square. Now summation x is 0. Okay, this is the concept of least square. So summation x 0. So what you will get? You will get the value of b, that is summation xy upon summation x square. Okay, so you can find the value of a and b with the help of these formula. So how to use the formula? Okay, how to formulate the formula? Is there anything to remember? No, nothing is there to remember. What we have to do, we have to find summation y. Okay, from this formula we have to find summation y, we have to find summation xy, and we have to find summation x square. So here you can see that already this is the y data. Okay, this is the y data. Okay, this is the y data. So this is summation y. Okay, this is summation y. So you can take the summation of all the data. Okay, you can take the summation of all these five data. So summation y will get 314,000. Okay, 314,000. Okay, so summation y has been already done. Okay, summation y we are getting 314 divided by y. So you can also find a value here. Okay, what you will get, a equals to summation y, that is 314 divided by n. N is the number of period. This is 1, 2, 3, 4 and 5 data. So divided by 5. So 314 divided by 5. Okay, so we'll get 62.80. Okay, you will get a, one of the constant we have got, that is a equals to 62.80. Now how to find b? So what we will do, you can see for b we have to find summation xy and summation x square. Okay, so what we will do, we will try to assign a value of x in such a way that the summation x must be equals to 0. The summation x must be equals to 0. So what we will do, you can see, first count 1, 2, 3, 4 and 5. It is odd, it is odd. So what we will do, take the middle, take the middle data. 2 and 2. This is the middle. Okay, this 1982 is the middle value. So what you should do? Assign this middle data as 0. Okay, assign this middle, that is 1982, assume it to be 0. Now we have two options. Either we have to move upward or we have to move downward. So what we will do? If we will move upward, then take negative sign, and if you are moving downward, then take positive sign. So 1982 will be -1. It is going to be +1. This is going to be -2, and it is going to be +2. So you can see the summation is 0. So we have to maintain a uniform gap. Okay, so if this is 0, this is -1, this is -2, this is +1, +2. You can see the gap is 1. Okay, so summation x is 0. So now what we have to do? We have to take xy. Okay, we have to take xy. So 50 into -2, it is going to be -100. 65 into -1, this is going to be -65. This is going to be 0. This is going to be 52, and this is going to be 144. Okay, this is going to be 144. Now take the summation of xy. Summation xy. After doing the summation of xy, we will get 31. Okay, we will get 31. You can calculate. Now the last column will be of x square. Okay, the last column will be of x square. So this is minus plus 4. This is plus 1. Okay, here we have got the x value. So this is 0. This is again plus 1, and this is plus 4. So summation x square we will get 10. Okay, this we will get as 10. So now what you are going to do? You are just going to put that value. Okay, so for b, okay, for b, summation xy. So this is 31 divided by 10. So this is going to be 3.1. 3.1. So what you can do? We have got our equation as y equals to a, that is 62.80, plus b, this is 3.1 x. Okay. So one of the answers we can do that, they are saying that find the trend data. Okay, find the trend data for 1985. So 1985, for 1985, what we will do? Y. Okay, y we have to find for 1985, that is 62.81 plus 3.1 into x. So for 1985, what is the value of x? You can see for 1984, the value of x is +2. Okay, so for 1985 we have to move in downward direction. You can see, and in downward direction we are considering the plus sign. So for 1985 the value for x will be +3. Okay, for 1985 the value of x is going to be +3 because we are moving in downward direction and we have to maintain the uniform gap. So after doing the calculation, it is going to be 72.1. Okay, 72.1. Now we have to write the answer. Okay, many of the students are making the mistake directly 72.1 rupees. So it is 72.1 thousand. So final answer is 72.1 into 1000. So it is going to rupees 72100. Okay, rupees 72100. So this is the answer for 1985. Okay, so the question answer for 1985 we have got. Okay, but the question is also saying that find the trend value for each of the 5 years. Okay, so what do you mean by trend value? So these sales, okay, these sales, that is 50, 65, 75,000, 52,000, 72,000, these all are the actual data. Okay, these all are the actual data, and the forecaster will try to find the trend data. Okay, the forecaster will try to find the trend data. So you can find the trend data for each of the year. Okay, so a new table you can make, that is for trend data. Okay, a new table you can make for a trend data. Okay, so these are the actual sales, and you can make a new table for the trend data. For 1980, just put the value of x to be -2. For 1981, just put the x value to be -1. So you will get the trend data. Okay, you will get the trend data for each of the year. And for 1985, we have got the this much of answer. So the forecaster will try to forecast this much of rupees, or he will expect that this much of sales is going to be happening. Okay, so trend data we can find. Okay, so trend data for each of the month we can find. For 1980, you can put the value of x to be -2. For 1981, you can put the value of x to be -1. For 1982, x equals to 0. 1983, x to be +1. 1984, value of x to be +2. So you can find the value of y. So you can calculate it. I have got the answer. For the first one, it is 56.60 thousand. 56.60 thousand. For the second one, it is 59.70 thousand. For the third one, it is only 62.81. 62.80 or 81. This will be 65.90, and this is going to be 69.00. So you can see that we have got a trend data, that is a increasing data. Okay, for each of the year the forecaster thinks that the sales is going to increase. You can see it is increasing. Okay, it is increasing in nature. So in this method the forecaster establish the relationship. Okay, so you can also plot the graph. Okay, for here you can take the year. Okay, this is 1980, this is 1981, this is 1982, 1983, this is 1984. Okay, here you can take the sales data. Okay, here you can take the sales data, sales in rupees. So the actual sales is given. Okay, the table was actual sales, so the actual sales may be like this. Okay, the actual sales may be like this. So you can plot it. Okay, you can plot it, and the original sale and the trend data will be like this. Okay, so this green color represent the this is not drawn to actual value. You can draw and check in your notebook. So this green color represent the trend data or trend value. You can see this is increasing in nature. And this red color line, okay, this red color line represents the actual data. Okay, actual data. So with the help of this, the trend data is also known as line of best fit. Okay, this trend data line is also known as line of best fit. Okay, so the aim of the method is to obtain the line of best fit. Okay, so this is all about the question in very detail. Okay, so these things will not be asked to you in the GATE examination. Only you to need to learn the process and up to here only. Okay, so they can ask that for 1985 what is going to be the sales. So this is the final answer. So you just need to calculate, but the everything has been done in detail. Okay, very detailed. So this is the year. You can plot the graph by plotting the actual values. Okay, just this is not done to the actual scale, so you can plot it to the actual value. Amrit Raj, happy chat sir, happy chat. Okay, so you can plot these things, and you can draw it to scale also. Okay, so this is all about the second question, method of least square. Okay, now we will take our next question. Okay, now we will take our next question. So this question is from queuing theory. Okay, this question is from queuing theory. This question is from queuing theory. Bittu Pari. Okay, so number of questions has been written. So in one question only, we will try to revise all the formulas of this chapter. Okay, so it says that at a telephone booth. Okay, at a telephone booth, at a telephone booth, arrivals are assumed to follow Poisson's distribution. Okay, so we know that arrival is represented with lambda. Okay, in this theory, the arrival is lambda, that is arrival rate. Okay, and since arrival is random, so it will follow the Poisson's distribution. So it is written, it is going to follow the Poisson's distribution because the arrival is random, and random things are following Poisson's distributions. So everything has been written in the question. So it is going to follow the Poisson distribution. Okay, and the unit is going to be the customer per unit time. Okay, time can be anything, it can be either hour or minute. So they are saying that arrivals are going to assume the Poisson distribution with average time of 10 minutes between two calls. Okay, average time of 10 minutes between two calls. So you can see the unit for lambda is customer per unit time, but it is saying that 10 minutes, 10 minutes for one customer, 10 minutes for one customer. So what we will do, we will try to find the time for 1 minute. Okay, the how many customers for 1 minute, so it is going to be 1 by 10 customers per minute. So 1 by 10 is our lambda. Okay, this is our lambda. Okay, so try to convert it into a standard unit, that is customer per unit time. So the lambda is 1 by 10, and it is saying that the average length of a telephone call is 4 minutes. Okay, average length means service rate, it is given. Okay, so they have given the mu. Okay, they have given the mu data. So what they have given, they are saying that 4 minutes, 4 minutes for one customer. So what we will do, we will try to find out for 1 minute. So for 1 minute, it is going to be 1 by 4 customer per minute. So this is the service rate. So service rate in this queuing model is represented by mu, and it is going to follow the exponential distribution. Okay, it is written, it is following exponentially distributed. Okay, it is exponentially distributed. So the lambda is 1 by 10 and the mu is 1 by 4. Okay, this is mu is our service rate and lambda is our arrival rate. So first thing they have been saying that first thing they are saying that average number of calls in the system. The first question they are asking, find the average number of calls in the system. Okay, so simply you know the formula, average number of calls or average number of customer. For A it is, for A it is for A it is, they are saying that average number of calls in the system. Okay, average number of calls in the system. So that was represented with LS. Okay, so average number of call in the system or average number of customer in the system. So the formula for LS was rho upon 1 minus rho. So it is going to be lambda by mu upon 1 minus lambda by mu. So LS will be lambda upon mu minus lambda, lambda upon mu minus lambda. So what you can do, you can just put the data. Lambda you can see, lambda we have calculated, this is going to be 0.1. 0.1. Mu, it is going to be 1 by 4, it is 0.25. Okay, it is 0.25 minus 0.1. So the average number of customer or average number of call in the system, ls, is lambda upon mu minus lambda. So this is going to be 0.667. Okay, 0.667. Now the second, they are saying that find the average number of calls waiting to be served. Okay, average number of calls waiting to be served. It means they are asking that average number of calls in the queue. Okay, waiting to be served. It means they are waiting in the queue. They are saying that the calls are waiting to be served. It means they are waiting in the queue. So the second one, they are asking about average number of calls in the queue, or they are waiting to be served. So simply they are asking LQ. Okay, they are simply asking LQ. So this was LQ was rho square upon 1 minus rho. So after solving it, you will get lambda square upon mu into mu minus lambda. Okay, lambda square upon mu into mu minus lambda. So this is going to be 0.1 square upon mu was 0.25. This is 0.25 minus 0.1. So the answer is going to be, you can solve it. So I have the answer 0. This is going to be 0.267. Okay, this is going to be 0.267. So this is the answer of the B part. Third, they are saying that average time a call spent in the system. Okay, C. Okay, C, you can see they are saying that average time, average time a call spends in the system. It means they are asking that average time in the system. Okay, there is the word system and there is the word average time. It means they are asking about WS. Okay, they are asking about WS. So what was the formula of WS? Okay, so we do not remember the formula of WS directly. We remember the Little's law. Okay, one of the law in the queuing theory was Little's law. So this Little's law says that the average number of customers in the system is going to be the product of lambda into the average waiting time in the system, that is ls equals to lambda upon ws. So we know the formula of ls, so from here we can calculate ws is going to be the ratio of ls upon lambda, and ls we have already calculated here. Okay, lambda upon mu minus lambda, so it is going to be 1 upon mu minus lambda. So what is mu? Mu is 0.25, lambda is 0.1. So this is going to be 6.67. This is going to be 6.67. This is going to be 6.67. Okay, very simple. You have to just look at the words. Okay, average time, and this is system. Now the D, average, again waiting time. Average waiting time they are saying of a call being served. Okay, so the D part, they are asking about WQ, average waiting time of a call being served. It means they are waiting in the queue. So for D part, they are asking about WQ. So again we can use the Little's law. They are saying that LQ equals to lambda into WQ. Okay, same. Okay, both are for system and Q only. So here WQ is going to be LQ upon lambda. So for LQ we know the formula here. So it is going to be lambda upon mu into mu minus lambda. So you can just put the value. Okay, you can just put the value lambda. We are knowing that it is going to be 0.1 and mu it is 0.25. Here mu is 0.25. So you can just calculate. So what you will get, WQ you will get 2.67. Okay, you will get the WQ as 2.67. Okay, so just the formulas are Becky. Only one marks question will be asked in the gate, and based upon these formulas only. Okay, so you just need to remember the formulas. Now they are saying that fraction of time during which the booth is empty. Okay, booth means system. Okay, booth is empty. It means the booth is ideal. So for ideal system, what we are going to calculate? For ideal system, what we are going to calculate? We are going to calculate the value of P naught. P naught equals to 1 minus rho. Okay, the system is ideal, or the customer is customer do not have to wait, you can say. Okay, the system is ideal. Okay, ideal system or empty system. Ideal system. Okay, so ideal system was 1 minus rho. So what is this rho? Rho was the traffic intensity. It was the ratio of lambda upon mu. So we can find the rho data. So this is going to be 4 by 10. So the rho value is going to be 0.4. You can calculate. Rho is the traffic intensity. So from here we can find that the probability fraction of time during which the booth is empty, that is rho naught P naught equals to 1 minus 0.4. So it is going to be 0.6. It is going to be 0.6. It means that 60% of the time the booth will be entry. Okay. Out of of the 60% of the customer's time, 60% of the customer time, the system is empty or it is ideal. Okay, so this is 0.6. Now they are saying that probability of at least one customer in the booth. Okay, probability of at least one customer in the booth. So this is going to be F part. So they are saying that calculate Pn where n is greater to be 0. So this will be equals to 1 minus P naught. Okay, this is going to be equal to 1 minus P naught. So we know the value of P naught. Okay, P naught is 1 minus rho. So we already know the value of P naught. So it is going to be 1 minus 0.6. So it is going to be 0.4. Okay, 0.4, it means it is BG. Okay, at least one customer is there. It means it is BG. Simply you can say BG probability. Okay, so this was the probability of ideal system, and this is the probability of BG system. Okay, BG system, or at least there is one customer in the system. And the last part they are saying that probability of more than 3 calls or 3 customer in the system. So they are asking that Pn, calculate Pn where n is greater than 3. Okay, so what we will do? We will do 1 minus P naught plus P1 plus P2. At least 3 customer. It means more than 3 customer or more than 3 calls. It means there should not be 0 customer, there should not be 1 customer, or there should not be 2 customers. So total 1 minus probability of 0 customer, probability of being 1 calls or 1 customer, probability of being 2 calls or 2 customers. So we are just subtracting these value from total probability. So it is going to be 1 minus, so what is P naught? P naught is going to be 1 minus rho. Okay, so directly write P naught plus P1. P1 is going to be P1. How we will write P1? P1 we will write P naught into rho. Okay, P naught into rho plus P2. How we are going to write P naught into rho square. P naught into rho square. So after solving this, 1 minus P naught we will take common. So it is going to be 1 plus rho square. Okay. So 1 P naught is 0.6 into 1 plus rho is 0.4 plus 0.4 square. Okay, so you can just solve that value, and after solving it, you will get 0.064. Okay, 0.064. So this is the answer. So you must, these are important. Okay, these are important. So mainly students are getting negative marks when these things are being asked. Okay, these are very simple. Okay, these are very simple, and these things have been repeated in gate a number of time. So just try to remember these type of formula when there is at least one customer or when there is more than three calls. So just more than three means just remove 0, 1 and 2 and subtract it with the total probability data. Okay, and you know how to calculate p1. Okay, anything pn, it means p naught into rho to the power n. Simply pn, probability of at least n customer or exactly n customer, probability of being exactly n customer in the system, it means pn is p naught into rho to the power n. So if you are going to calculate p naught, so it is going to be p naught into rho to the power 0. This is p0. P1 equals to P naught into rho to the power n. P2 equals to P naught into rho to the power 2. So just I am writing these value here. Okay, I am writing these value here. So from here only you can take these value. Okay, you can take these value. Okay, so this was the formula of probability of exactly n customer. Okay, so P naught means there is no customer. P1 means there is one customer, and P2 means there is two customer, and one minus these three will be more than three customers. Okay, so very simple. So almost all the formulas I have covered with the help of this numerical. Okay, you can see average number of calls. Okay, average number of calls in the system. This was our ls. Okay, average number of calls waiting to be served. This was our lq. Okay, ws. This was our wq. Okay, here we have calculated the ideal system, that is 1 minus rho. Okay, p naught equals to 1 minus row. Here also I have Pn where n is greater than 0, Pn where n is greater than 3. So almost all the formulas. Okay, these four are very much important. These four are very much important, and almost every 2 to 3 years, these four formulas have been asked. Okay, directly. Okay, directly. And these two you should not remember. Okay, ws and wq. There is no need to remember these formulas for ws, average waiting time in the system, and average waiting time in the queue. You should not remember this formula. What you will do, you will just try to remember the Little's law. Okay, you will just try to remember the Little's law that says that average number of customers in the system is equal to the product of arrival rate into the average waiting time in the system, and average number of customer in the queue is equals to the arrival rate multiplied by the waiting time in the queue. So this lambda is the arrival rate, and here mu is the service rate. Okay, and unit is also same. Okay, for both lambda and mu, the unit is going to remain the same. It is also going to be customer per unit time. This time can be anything, per hour or per second, but for both lambda and mu, the unit will be same. This is also customer per unit time. Okay, and generally for our syllabus, mu will be greater than lambda. Okay, so this was also a 1 marks question in a year. This was also asked. Okay, so the value of mu should be greater than lambda for a single server system. Okay, for a single server system there can be single or multiple server system, for but for our syllabus we are studying a single server system. So generally mu is greater than lambda for a single server system. So in this lecture we have done the question on inventory, sorry, forecasting and queuing theory. So in the upcoming lecture we will see some new topics which will be beneficial for your paper, and just try to use the code Gaurav 10. Okay, just try to use the code Gaurav 10. Okay, this is the code, and by using these code you will get a 10% discount. Okay, 10% discount on Ekeeda GATE subscription. Okay, so you can just use the code Gaurav 10. Any branch student can use this code, By using this code, you will get a 10% discount on the Ekeeda GATE subscription. Okay, so if you want the code, if you want the course, or if you want the discount, so use this code, that is Gaurav 10. Okay, so this is all about today's lecture. Thank you very much. Now we will meet on the next Thursday.